Hello and a really big warm welcome to this presentation from Pluralsight. My name is Andrew Mallett and I'm going to be your instructor as I help guide you through the module Managing File Storage in Linux. So yes, our Linux storage devices. We'll be concentrating mainly on our local devices, so disks, and we'll also see that we can use disk files. But of course we can have remote storage, such as Storage Area Network, or SANs, where we're sharing out raw disk space, or maybe file system servers, such as CIFS, perhaps in a Windows environment, or NFS in a Unix environment. When we look at some of the commands that we can use, we can go back to our wonderful ls family and look at listing our block devices with ls block. If we just want to stick with the simple ls command, why don't we go through and look at our device files that represent our storage devices? Or even going through, sorting our files in the etc directory and listing them by their file size. If we reverse search, we're going to be able to go through and show the largest files last, which is obviously something we might be interested in. We can also see how much space is being used by a directory, and we can check how much free space we have on a mount point. Here we're looking at the complete file system root. But do you know what I think? And I also know that you shouldn't really care about what I think. It's about what's important to you. And I think getting out on the command line is going to be really important to you. Come on, are you going to join me? And let's celebrate this, our glorious command line. Let me just move the cursor down just a little bit so maybe it's easier to see. And we're going to begin with the ls block command so we can go through and list our block devices. Now you can see that Ubuntu makes good use of loop devices. Loop devices connect disk files to disk devices. The disk files that we're seeing at the moment are coming from the Snap package manager. When we install something through Snap, we're actually downloading a file system and we're connecting to the system through these loop devices. We're mainly interested in our physical disk, SDA, and maybe even when we take a look at it, we've got our CD-ROM devices, SR0 and SR1. When we look at the major and minor number, this is identifying the driver. The driver is uniquely identifying the type of device that we're looking at. The major number of our physical disk is 8, and of our CD-ROMs, it's 11. And let's go back up and look at ls block, minus uppercase I to include. And let's look only at 8 and 11, those major numbers. So now we're able to filter out our screen, so it's a lot easier to understand. So our physical disk SDA is 75 gig in size, and we have two partitions, a small partition that isn't mounted and a 75 gig partition that is mounted to the root file system. When we look at our CD-ROM, we have an 88 meg CD-ROM and a 5.8 gig CD-ROM. So it gives you an idea of the file systems that we have connected. The only mounted file system at the moment is SDA2, mounted through to our root file system. Now we can stick with our block devices for the moment, but let's use our ls command. ls-l will give us the metadata. We can look inside our dev directory, and if we look for files beginning with SD, not for storage devices, but for SCSI devices, the standard since kernel 2.6 for managing our disks, and the wildcard asterisk. As we start looking at the output, we're able to see then that we've got our SDA, SDA1 and SDA2. Just be careful, though, of the middle values. Normally, this would be the file size, but for our devices, we can see it maps to the major and minor numbers. But let's also compare the output of a block device with a standard file so we can see what we mean. If I just go through and quickly do a long listing of the etc host file, we can see that the middle metadata is 221. That's representing 221 bytes, rather than the major and minor numbers that we see for our device files. But if we are going to spend time looking at our file systems, why don't we look at the entire etc directory? But of course, I'm going to be getting a lot of output from that. So why don't I go through and just start adding in some extra switches? I'm going to go through and put H for human readable because bytes become difficult as the files become larger. As we go through, I can sort the output, and I want to sort the output on the file size. So let's put in uppercase S, and I want to reverse sort so I can see the largest files towards the end of the output. Now, as we start listing it, we can see then very easily that 74K represents the largest file and MIME types. If I change the sorting and remove the R for reverse sort, we can see now I see the smallest files at the end of the screen, and I've got a couple of 0-byte files. Another really useful tool is to check the size of the entire directory. So DU for disk usage, minus S for a summary, so I only see the size of the directory, not each file, and H for human readable on etc. Now, of course, I'm getting a little bit of error output because I don't have permissions to the entire etc structure. That might not make a lot of difference, but I can see that the output shows as 12 meg. Let's tidy the output so I can repeat the command, and if I redirect my error output to /dev/null, a special device file, I can see then only my standard output. I don't see the error output, and we can easily see at 12 meg. Another really useful tool, if we wanted to check it with sudo, so as root, just go sudo and ! This will repeat the last command in its entirety, but with sudo in front of it. And of course, I need to authenticate to sudo to elevate the privileges, but we can see then it hasn't made a huge amount of difference as I'm now able to access the whole file system, and we can see then it's 12 meg. Another really useful tool that you should be using is checking the disk free. So let's go through again in human readable and check for our root file system, and look at that. We can see we've got plenty of space available, 57 gig.